thank you very much and welcome everyone, both in person and online. So today we're going to invite you on a journey of discovery, one where we navigate the often complex maze of information using the compass of human-centred design. Through this approach, we aim to bring clarity by creating engaging, relevant and insightful outcomes that drive real impact. Human-centred design empowers us to listen more deeply and connect more meaningfully, enabling us to provide advice, services and science that's not only effective, but also grounded in real-world needs. Our goal is simple but powerful, to ensure that what we deliver is clear, valuable and continuously impactful for all of Australia. As with any meaningful journey, a clear path forward always helps us stay aligned. So today we'll be looking at the chaos of complexity that Geoscience Australia walks in, gain a greater understanding of what human-centred design is, explore 3 case studies where human-centred design has helped us in gaining a better clarity to the chaos, and reflections on our continuous journey towards providing more impactful experience and outcomes to our stakeholders. We'll start by briefly looking at the Geoscience Australian context, who we are, the challenges or chaos and complexity that we face, and how human-centred design can provide us with clarity. As the nation's trusted source of information on Australians' earth sciences, Geoscience Australia empowers decision-making by government, communities and industry. The breadth of our work covers the uniqueness of our island continent, our extensive marine jurisdictions, and includes our frozen territories in the Antarctic. We are innovative, respectful and collaborative in leading earth sciences for government, communities and industry. Our science contributes and provides invaluable impact to a stronger economy and a resilient society for all of Australia. As the nation's trusted source of information on Australia's earth sciences, we do, however, have some challenges. Firstly, we're not just doing science. We're balancing multiple hats of robust applied science, actionable advice, as well as practical tools for government, industry, education and research. We're also working across the landscape of competing interests, values and goals. We're also gathered powerful data and created incredible tools. However, the challenge now is shaping this complexity into more insightful, impactful and meaningful outcomes. What appears as chaos is in fact a complex and ordered system, and our role is to chart the most effective course to support and guide others in achieving success. Human-centred design gives us a path through this maze of complexity. Not a perfect one, but enough to stop walking in circles. It is a guide when the people we serve need clarity, not just data. When science alone doesn't always provide clear answers, how through continuous learning and iterative people-centric improvements, we can move from the tangle of information and data to something clear, usable and impactful. However, before we get into how human-centred design has supported us on our journey, let's quickly explore why it matters and how it works. Human-centred design is a creative approach to problem solving that starts with people and empathy and ends with impactful solutions to complex problems tailored to their needs. It's an iterative practice of improvement through continuous learning. Think of human-centred design as a science for understanding people, where there's hypotheses, testing, iterations, but with emotions, context, behaviour and lived experience. It is not just a framework, it is a mindset that shapes how we plan, prioritise and deliver everything that we do. It's not just for interface design or service improvement. It can also be applied to the hard, messy problems. The core idea behind it is people first while balancing innovation and practicality. It values empathy for deep user understanding, ideation for inclusive wide-ranging idea generation, prototyping and testing for small, fast experiments, but with users, and iteration, where we use feedback to learn and refine. Human-centred design, or HCD, helps with navigating ambiguity to find the real problems and decisions, to verify, not to assume. provide clarity and understanding, not just solutions, tools and data, and also helps us stay curious, assuming nothing, learning everything, continuously improve, and making sure that we always provide value. In HCD, the ideal sweet spot for excellence and great solutions lie in the intersection where desirability, viability, and feasibility meet. In desirability, you seek to understand who are our users and what do they need to achieve their goals. For viability, you need to question where can we deliver and derive real value? Will it be sustainable and have the ability for long-term success? And finally, feasibility, where you need to consider the overall technical, science and resource practicalities, and how might we best deliver products and services to meet those desires and needs. Human-centred design ultimately starts with desirability, but you must also account for the other two in order to really succeed. It's about balance and compromise, as it is understanding that you cannot always fully meet all three. So let's take a look at the human-centred design process in action and how it aligns with the phases many of us may already work within, especially in the digital government and service design contexts. You might have come across two key frameworks in this space. That's the Double Diamond and the Digital Design Standard from the DTA. The Double Diamond is a design framework developed by the UK Design Council. It maps out the process of diverging to explore the problem space and then converging towards solutions, done twice, once for the problem and then one for the solution. It represents the divergent and convergent thinking that happens within the design process. There's two diamonds. First, the diamond is about understanding the problem, diverging to explore, then converging to define it more clearly. And then the second diamond is about solving the problem, generating ideas, prototyping, testing, and then refining. The second framework, that's the Digital Service Standard Lifecycle, is used by the Australian Government and digital teams to guide service delivery. It includes the phases of discovery, so understand user needs and the service landscape. Alpha for rapid prototyping to test ideas and assumptions. Beta for building a working solution, testing with real users. And then live for the service rollout and for continuous improvement. So how are these different? The Double Diamond is a design thinking model focused on how we think and explore creatively. The digital phase, however, are a delivery model giving us a roadmap for managing and funding digital services, especially in government. They approach the same challenges, but from different angles. One from the perspective of thinking, and the other from the perspective of doing. Here at Geoscience Australia, we have been exploring about combining the two. So why would we be looking at this? By overlaying these two models, we get a clearer picture of how design thinking and delivery align and where we are in the journey. Mapping these together, the discovery phase fits within the first half of the first diamond. Here we explore and understand the user landscape and the problem. This is where empathy, research, and engaging users through open-ended inquiries matter. Alpha starts towards the end of the first diamond. As we begin defining the problem clearly, it then flows into the start of the second diamond, where we prototype and test the possible solutions. Here, we are generating the ideas, sketching out the concepts, and learning quickly through feedback. Beta sits firmly in the second diamond, about scaling and refining those ideas, continuing the convergence of the second diamond, but with more rigour and testing out greater scale and involving real users in real environments. And finally, live. This represents where the solution is launched, where the feedback loop continues, with continuous improvement and ongoing monitoring. We keep iterating based on user behaviour, so the design doesn't stop. It just becomes more embedded in the delivery, because good services are never truly finished. So why is combining these useful? Combining them gives us a clear structure that speaks both to design thinking and delivery frameworks, which is especially helpful when collaborating across disciplines like science, technology, and service operations. It helps teams to stay user-focused while still being aligned with the project governance, delivery and funding stages. Most importantly, it reminds us that good services aren't designed in a single burst. They're iterative, user-tested and grown over time. It gives everyone a shared language so we know not just what we're doing, but also why we're doing it and then what comes next. So when we merge these frameworks, we get the best of both worlds, a robust design process that's also practical and aligned of how services are actually delivered in real-world environments. So I know what you're thinking, that sounds great. So what does human-centred design actually mean? So what is it in reality? Broadly, the process includes inspiration, understanding the context of the end users, ideation, which generate and narrow ideas. So it's generating diverse and creative ideas from talking to those that we serve to better understand them and their needs, and addressing pain points, their needs and desires, narrowing them down into promising concepts, testing the hypothesis and iterating, ensuring that we're addressing the right problems. And finally, to implement and monitor, build, test and refining, building and delivering the best solution and understanding for the users, and continuous monitoring and validating the solution to ensure its ongoing value. It includes a wide variety of methods, tools and outputs, such as user research, UX/UI design, user testing, service mapping and design, technical mapping, lean UX, agile, journey mapping, wireframing, low and high fidelity prototyping, and much, much more. So why does human-centred design matter at Geoscience Australia? We want to create a consistent, meaningful and evidence-informed user experience across all digital and service touchpoints, where every product and service considers real people, delivers measurable value and creates consistent and unified experience. Human-centred design helps us to drive better outcomes by designing around real people's needs not assuming. It reduces risk and increases efficiencies by better balancing cost and efficiency by learning what works early. Builds trust and usability in our products and services, especially when they're complex or specialist. And making science accessible, translating geoscientific data and insights into usable products and services that are created with real people in mind. Improves collaborations from scientists, developers and leadership at Geoscience Australia to our partners and collaborators and end users. It also strengthens stakeholder value by ensuring that our services are built with impact in mind. So over time, Geoscience Australia has been gaining maturity in navigating complexity. Agile delivery has been applied within Geoscience Australia since the adoption of the agile practices over the last 10 years, maturing within about the last 7. Lean UX and feedback loops from users with rapid enhancements to science, digital tools, features and functionalities have also been applied for some time. However, there's always room for improvement, with some newer processes are also bringing more value. With human-centred design, however, allows us also to bring us another tool to the toolbox. The discovery, define, alpha, beta, live approach ensures assumptions are continuously tested and refined. Although the organisation is very effective at development and delivery, we've had limited experience in maturity in the user research for problem definition and user experience designs. Also with the lean service design has been brought in more recently, which has enabled us to streamline unnecessary complex processes and creating large-scale efficiencies. We have found that it is most effective when it is used and adopted to each situation and applying what works rather than by blindly following strict methodologies. So bringing the HCD magic to life through real-world examples and experiences, we'll now walk through 3 projects where HCD has helped us to move from complexity to usable, trusted solutions. As the nation's trusted source of information on Australia's earth sciences, we hold a vast holdings of geoscientific information. We have an extensive repository, includes general to complex scientific information for diverse stakeholders across government, industry, academia and community who rely on this knowledge to make informed decisions about Australia's resources and environment. Information related to these scientific resources are located within our Enterprise Catalogue, or ECAP for short, also known as the Data and Publication Search. The ECAP system serves as a vital digital gateway, housing over 64,000 records, including dataset, research documents, geological maps, scientific code, and web services. It is a major resource where diversity of content has people sometimes struggling to access the right information they need quickly and effectively. Although the platform underwent a recent update, this was largely based on functionality. With this update, there has brought some changes. However, people expect modern, intuitive interfaces that address evolving technology expectations and the community's growing demands for accessible, authoritative geoscientific information. Additionally, they seek to access the information quickly and with very little barriers of entry, an experience that keeps them coming back for more and more, coming back again. In supporting our open data, the catalogue is open to everyone, so this adds an additional complexity. Knowing who utilise it, how they do and wish to use it, and for what purposes, was somewhat an unknown mystery. As such, we wanted to develop a deeper understanding of our users to be able to create more impactful experience. With the assistance of Hide or Seek Digital, we undertook a 3-month discovery phase to understand the current lay of the land. The process included workshops, interviews and surveys, with 53 active participants on the internal workshop. Surveys was open for about 4 weeks, and we had about 68 external survey respondents, 40% of which worked in the public service from 8 different government organisations. We also conducted a landscape review of comparative products and services to understand how users already are engaging with similar catalogue platforms, assessing 10 platforms across Australia, the UK and the US. Also conducted process mapping, which captures workflows and technical dependencies, conducted audits of features, functionalities, search, content and data system performance, did a heuristic evaluation with reviewing ECAT's performance against design standards, and finally, research synthesis, turning the data and insights that we've gained into recommendations and outcomes. Outputs from this process included user journey and service blueprints, jobs to be done register, a search model map, technical ecosystem map, system performance assessment, content and data types classification, current feature lists, and UI/UX benchmarking report. The discovery phase revealed challenges and significant opportunities for the catalogue. It provided us with a deeper understanding of our users, what their key needs are, by analysing recurring patterns in behaviour, pain points and motivations across our research data. From this, 6 archetype groups with similar needs were identified. This included the scientific researcher, geospatial analyst, data steward, public information seeker, policy analyst and industry professional. Users consistently praise ECAT as an invaluable and comprehensive repository of Australia's geoscience knowledge, describing it as essential for their research and unmatched by its coverage. From the external surveys, 92% of survey respondents rated the quality of information good, very good or excellent. However, this wealth of content becomes difficult to access when users struggles to find the specific resources, with many noting that discovering the right information requires multiple search attempts. By addressing immediate functionality concerns while maintaining planning strategic enhancements, the catalogue could transform into the best-of-class scientific data catalogue. The discovery phase is the first in the HCD process. These findings will go on to informing the next stages of Define and Alpha as we continually learn and apply insights towards this goal. Our next case study went beyond just discovery, moving through all the phases of the HCD process. As discussed, Geoscience Australia has extensive holdings of geoscientific information, ranging across many scientific disciplines. The quality of the data available in the geosciences is expanding rapidly. Unfortunately, due to the density and complexity of the information, key stakeholders and decision makers that need to take into consideration different but related scientific information gets lost. Geoscientific data is also complex, requiring specific and unique ways to capture, process, store, and deliver and display. This complexity, along with the density of data, which can be sometimes up into the petabytes, can significantly impact user experience, as business models, culture, processes, and technologies struggle to meet the rising expectations of people in the current era. Added to this, geoscientific information, that is the interpretation and representation of the data, can also be confusing to non-technical people, let alone when people need to make effective decisions that need to take into consideration related but different scientific disciplines. Over the years, Geoscience Australia has done a fantastic job in the capture, management, and the delivery of geoscientific data. However, as we talked more with our stakeholders, it became more apparent that we were leaving behind an important group. That was the non-technical decision makers, that being non-scientific, non-geoscience professionals, which rely on Geoscience Australia to provide up-to-date advice in a clear, usable way. Our aim was a pilot in which we could develop a new approach of communicating geological information to non-technical audiences, and that is the non-geoscientific professionals. Geoscience was an 18-month project delivered at the later part of the Geoscience Exploring for the Future program. It was an initiative driven by Minerals, Energy, Groundwater Division and the Enterprise Data and Digital Divisions. For more information, please see Dr. Catherine Waltenberg's DGUL presentation available on the GA website. The process included expert ideation workshops to explore the potential user stories, also an in-depth look at the areas of groundwater, minerals and energy, and what data and information existed, using specific regions as a use case and affinity mapping for how they may be integrated together in a usable way. A second ideation workshop explored potential ways in which the information could be displayed and accessed in a first-pass design. With the assistance of Future Friendly, a series of wireframes which evolved through several user testing rounds, focused on non-technical stakeholders, combined with technical engagement to ensure alignment and patterns. Finally, Low Fidelity prototype produced and used a reference by the development team to create a pilot through Agile and DevOps processes. Some of the key learnings from this was that people want information that directly relates to the problems that they are working on. The details in which can come later. Interviews and testing found that users wanted simple and fast, plain language experience, which provided basic information and provided pathways for future research. Using a HCD approach, we were able to develop a pilot that provides an accessible experience that curates information and data from across the Geoscience Australia ecosystem, helping users make decisions and refine their research approach quickly and confidently. The Geoscience pilot was released in August 2024 and won the 2024 Good Design Award for its design approach. So let's take a quick look at the pilot and what you can do with it. So welcome to Geoscience, your interactive tool for exploring resource data across Australia. From here on the landing page, you can quickly understand what the platform offers and easy navigations begins your journey. You can go through the Get Started, select the topic that you're interested in, go through the dynamic map, and also generate a report with a summary of the information. The report compiles a regional summary with key insights, maps, and data visualisation, perfect for decision-making, reporting, and further analysis. That was a very quick one, so please feel free to go to geoinsight.ga.gov.au if you'd like to play around for yourself. So Geoinsight is a fast, flexible, and built to support informed decisions, so yes, please try for yourself. Our next case study is our most recent of Geoscience Australia's largest HCD projects. As global dynamics continue to evolve, strategic priorities are shifting, leading to increased demand for critical minerals data and information across the Australian government. This trend underscores the growing necessity for accessible and transparent information regarding critical minerals. Critical minerals information increasingly needs to be accessible to non-geoscientifics in a clear, responsible and accessible way. The Australian Critical Minerals Research and Development Hub is a partnership between Geoscience Australia, CSIRO and AGSTO. And they wanted to know how could we optimise information services to meet the current and emerging needs of government stakeholders, enabling informed policy development and strategic decision-making in the critical mineral sector. The answer, ask. Sounds simple, right? However, as always, the devil is in the detail. The challenges that we faced in this space could be categorised into people, technology and process. People. Many of Geoscience Australia's current products and services were designed and evolved to serve the needs of industry users. This amazing, practical and highly regarded tools focus on highly technical users of geoscientific data. Stakeholders also need rapid access to a wide breadth of current and curated geoscience information to make informed policies and strategic decisions. And as mentioned, non-geoscience professionals are struggling to understand and compare critical mineral information clearly and confidently. In technology, and added to the complexity of high-quality geoscience data, there's also many issues that we need to address in that space, such as storage, processing, and delivering the information in a rapid and usable way that meets data and design standards. And finally, process. Teams within Geoscience Australia were also new to the human-centred design approach and wasn't quite sure what to expect. As we wanted to better understand our users of critical minerals information within government, we utilised the HCD process. As we moved through discovery, define and alpha, each stage providing evolving insights that were iterated upon within and through each. We gained increasing clarity for achieving the best balance of desirability, feasibility and viability. Supported by the Australian Critical Minerals Research and Development Hub, the Critical Minerals Human-Centred Design Project was a joint initiative of Geoscience Australia's Mineral, Energy and Groundwater and corporate divisions, namely the Mineral Resources Advice and Promotions teams, Strategy Analysis, Mineral Potentials of Australia, Information Services and Enterprise Data and Digital. The project began in August 2024 with the discovery phase, supported by the Department of Industry and Science and Resources Service Experience section, followed by the define phase in December. Alpha stage began in February 2025, assisted by Hide and Seek Digital, and was broken into 2 prototyping phases. 12 months since we started the project, the beta phase has begun this month, with the development by the Enterprise Data and Digital technical teams responsible for the scientific applications such as earthquakes at GA, Digital Earth Australia hotspots, Geoscience Australia portal, GeoInsight and many more. Along with minerals, energies and groundwater geoscientists and geoscience subject matter expert teams. We'll now be looking at the stages and the approach taken and the clarity that we gained as we went. About a 3.5 month discovery engagement, an additional 1.5 months for the define phase were undertaken, during which an in-depth qualitative analysis was undertaken with users of critical minerals data across government. This was supplemented with desktop research, background information and a brief review of the existing portals. It also included the ideation workshops and stakeholder validation activities to identify those areas that deliver the best impact. From this, and the clarity that we gained, was that users could be categorised within a number of user types. This allowed us to gain deeper understanding of their unique needs, behaviours and capabilities and experiences. It identified 4 archetypes within the government user cohorts, which included the advisor, which responds to requests for policy advice or information, often identifying new policy ideas or validating assumptions. The analyst, which applies their analytical skills to identify reliable data sources and transform raw data into meaningful insights, often in a report or a publication. The decision maker, assessing foreign investments, either formulates decisions or provides recommendations to a delegate. And the promoter, that advocates for Australian critical minerals industry to support the Australian economy and secure international investment. Across these archetypes, discovery also uncovered 5 traits about how each of them engage with critical minerals information and the Geoscience Australia's products and services. Ratings on these traits illustrates preferences and needs, not higher or lower ratings should not be interpreted as sort of more and less favourable. So these traits included data literacy, so the level of data literacy such as analysis, cleansing, visualisation that the person required in order to perform their role. Critical minerals literacy, so the amount of subject matter expertise they needed within critical minerals. The importance of critical minerals data in their role. The tendency to self-serve, so the propensity to seek out critical minerals data by independently searching data information sources online, rather than consulting others to get what they need, as well as the need for raw data, so the requirement for raw data sets as opposed to summarised informations or insights. Some additional insights that we gained from this process included that users felt overwhelmed by the breadth of functionality of GA's online products and services, making it difficult to clearly understand and value each. Awareness of Geoscience Australia's online products and services was also low, creating a reliance on direct requests. There's also data gaps in the lack of transparency in critical minerals sector that could lead to underinformed decisions. And also a lack of entry-level critical minerals information, which results in a steep learning curve to upskill. And finally, critical minerals data is also most valuable to government users when it's layered with other information. However, this is a highly manual process and has risk of human error. In the define stage, from the insights we gained from discovery, there were several technical and non-technical propositions and future state initiatives outlined and how we could improve the current experience and value for government users. These included to make easy to find data and information, uplift critical minerals capability across government, or streamline data compilation and analysis. Discovery and define stages helped us to start to bring clarity and structure to understanding who our stakeholders were and how they rely on critical information and what their experiences had been. Alpha stage then enabled us to take these learnings and start to build out something more tangible to address the stakeholder needs. A 4-month engagement focused on understanding and transferring the outcomes from the early phases, into a low fidelity prototype. The process included workshops, interviews, such as which included the story of a mineral exercise. That makes a critical mineral the star of the show. We took the perspective of the mineral and people were encouraged to think about the story that it could tell. This was important as the minerals were the central to our design. It's also included the how might we exercise, which encouraged divergent thinking amongst the team, allowing possible solutions to challenge areas identified in discovery more broadly. We then applied convergent thinking through prioritisation of the possible solutions, where the following were identified as possible quick wins for the interface design. And also card sorting exercise. In the past, we generally relied on subject matter experts sorting information for our products and services. However, putting people first, we wanted to see how they viewed critical information themselves. There was also a landscape review conducted, which included the user testing of the current portal, a comparative UI/UX assessment of how other agencies and companies in other sectors approach user interface design, and data visualisation, as well as low fidelity and internal testing. Outputs from the process included job stories, so a customer-centric approach providing rich context about precisely when and why users needed certain features. This is which translated to when, so the situation, I want to, the motivation, so that I can, and the expected outcome. Other outputs include feature prioritisation, also grayscale wireframes, where we began to create a comprehensive set of wireframes to clarify the portal's overall structure and the user journeys before advancing to a full design. Presented in grayscale, these wireframes emphasise features and functionality, content placement, and navigation, establishing a key framework for the stakeholder feedback. And as well as also included 3 visual concepts designed for us to select from, where we explore a variety of solutions inspired by the story of a mineral activity, aiming to present critical minerals information in an easy digestible way, while still offering a richer experience for those who wanted to dive deeper into the data. From all of this, we had quite a bit of learning, but some of the key learnings was, for us, the advisor and analyst archetypes were more likely to engage directly with critical mineral content and pass relevant information to the decision makers and the promoters, and where we could actually deliver the greatest impact. In the landscapes assessments from the usability testing, these sessions largely reinforced themes from the original discovery phase, but critically enhanced our team's ability not just to understand what the challenges were, but to witness the users engaging with Geoscience Australia's interfaces, including the portal maps. This direct observation revealed specific navigation patterns and user experience barriers that informed our design and decisions with greater precision and confidence. The comparative UI/UX assessment. This evaluation identified both usability strengths and weaknesses across the sector, highlighting emerging design trends and revealing opportunities. Our findings revealed that muted map base layers significantly enhance data visibility by creating stronger contrast with colour-coded information layers. Also, concise information snippets improve clarity and comprehension, while integrated charts alongside map data delivered more comprehensive and engaging user experience. With the car sorting exercise, people liked information organised into clear thematic grouping with strong consensus on technical categories. People also preferred navigating information via the groupings and patterns and locations. Through the prototypes and designs with the wireframes, this helped us to validate the essential design elements at an early stage and ensured that our next steps were grounded in solid, user-centred insights. And with the visual concept designs, not surprisingly, the more visually engaging and relevant, the more impactful the user experience is. We moved into the final alpha stage, which focused more on verifying and refining the design. This 3-month engagement focused on user testing and turning the low-fidelity prototype into a more high-fidelity prototype design and detailed development-ready visual designs. The process included 2 rounds of usability testing against 10 scenarios with external users, noting we did have a little trouble recruiting participants in this round, namely due to availability and the short timeframes that we had. So just a note to make sure that you engage with those user segments you want to test with early and allow for time. But as we all know, that's not always the case. With this, we will continue to test with users and continue to refine the portal for the best-in-class experience. With the high-fidelity prototyping, we created a clickable prototype to emulate the final product for users to really understand the workflows and to give them the best experience and for us to get the best possible feedback. Also, with the detailed visual designs, we applied the digital designs from the concepts in phase 1 to the rest of the wireframes. Outputs from this process included detailed Figma designs, includes the beginnings of a reusable design system. The clarity that we gained from all of this. So, firstly, not all our ideas and designs actually translated into usable and value features. This actually enabled us to ensure that what we were delivering was able to gain more impactful improvements, and it showed the importance of hypothesis, test, learn, improve, and test again. Of those engaged in the testing, had an overall success rate of 94% in completing all the 10 scenarios, which for a first time and non-technical users was an actual impressive outcome. Users really valued the prototype, describing it as intuitive, visually appealing, dramatically faster and more coherent and accessible than the current products. Additionally, the development teams appreciated the level of detail in the prototype. Rather than just being handed something scribbled on a page or even a 2D design in Paint, 3D designs that included inbuilt specifications, ready-to-access style code snippets, and more aligned to the Web Content Accessible Guidelines, also known as WCAG, and style guides, provides reusability for future changes and high-level confidence development, We've already started to actually integrate some of these design improvements into our main product suites, and we've already started to receive some great feedback from users. The iterative testing and refinement led to a final prototype that users have found engaging, simple to use, and effective in supporting confident and informed decisions. So let's take a quick look. So welcome to the Critical Minerals portal, your one-stop platform deep dive insights into Australia's critical minerals resources. From the homepage, you can quickly get orientated and dive straight into data exploration. In the Get Started, you can select individual minerals or grouping. In this example, we've got cobalt, manganese, and Tuscan. I'm sure I've said that wrong. These sections carry through to the entire experience in the context and kept consistent throughout. Next, we look at the graphs. We can explore interactive graphs, all dynamically linked to previous mineral selections. You can also look at related graphs to get deeper insights in production, supply, and demand needs. With the dynamic map, you get helpful tooltips as you go, and a sidebar explains what you're seeing, including those selected minerals, visible layers, and project statuses. You can switch between base layers, explore project status, and map charts, and see that your minerals are still, and so you can still see that your minerals are active. You can also expand to get more detail. This is not real data, by the way. So. The map also highlights mineral export flows and hover if you can get more information. And finally, check out the publications curated for selected minerals or just any of the critical minerals, from government reports to industry briefings, all linked in one place. So the Critical Minerals portal is designed to give people, particularly non-geoscientists, the tools they need to make informed, data-driven decisions for Australia. The redesigned portal demonstrates measurable impact across key user groups. For researchers, it provides clearer pathway to data sets, improved visualisation tools, and a stronger understanding for relationships between information. For industry professionals, it reduces the time spent piecing together data and enables streamlined access to operational and export statistics. For policymakers, it delivers presentation-ready dashboards and evidence-based insights that could directly inform decision-making. Most importantly, this work shows how human-centred design can transform the way government data services the nation. By making critical minerals intelligence more accessible, the portal strengthens Australia's position in the global resources sector and empowers stakeholders to make confident, well-informed decisions. It is a platform designed not just for today's needs, but to evolve with the demands of tomorrow. Our human-centred design journey has taken us down many paths. Each time we have come through with a clearer picture of the maze and a greater ability to lay the way for other success. The human-centred design approach has helped us to bring clarity to the complexity and deliver more impact value by enabling us to ask better and smarter questions, to see the bigger picture across science, government, and industry, to engage users without dumbing down the science, to turn complexity into shared understanding, and design tools, products, and services that people actually use. It's also helped with co-design across silos to build mutual trust and a clearer information to decision makers. However, this is only the beginning. As an organisation, we're employing human-centred design as an ongoing mindset and practice, particularly in changing the way we do digital delivery. Other human-focused initiatives leading the way include Resourcing Australia's Prosperity Initiative, where we're applying human-centred design approach to the second-generation geoscience data delivery capability, set for delivery in the 2030. Also, the Geoscience Australia Human-Centred Design Playbook was taking leading human-centred design guides from the Digital Transformation Agency, Victoria Government, DISA industry to develop a playbook tailored to Geoscience Australia context. Also, the lean service design through the organisational transformation project is streamlining internal processes and creating efficiencies through leaner, user-focused services. And also with the Digital Atlas Australia through their continuous improvement, and Digital Earth Australia with the upcoming product-wide review. Human-centred design provides a powerful compass when navigating the maze of complexity. When trying to address complex but interesting problems, it enables and empowers us to more effectively listen and connect in such a way that we can design to meet the real-world outcomes, ensuring that our science, advice and services are clear and continuously deliver value and impact for all of Australia. Clarity in our world doesn't come from simplification. It comes from listening, connecting and designing for real-world impact. And as always, this is not an individual effort, it is definitely a team effort. So just wanted a very quick thank you for the many people that have contributed to this journey and continue to contribute. Thank you.